We're going to be talking about how to use your calculator with some exponential expressions. And I'm talking about something like this, raising 2 to the third power. Now I'm using this one because we already know the answer to that without using our calculator, but we should be able to punch this into our calculator, make sure that we have found the correct button. So on my particular calculator, let me come in a little bit closer. You can see I have a TI-30X. You use whatever scientific calculator it is that you have. So on my calculator, I'm going to press the 2, and then you need to find the, I'm going to turn my calculator on, and then I'll press the 2. You need to find the button that says you're going to raise the number to a power. On this calculator, you'll see it's a caret. It looks like this. So there's the button. You might have a button that looks similar to that, or you might have a Y to the X button, or an X to the Y button, or maybe it's an X to the, and I've seen it with a box there. Find the button that will tell the calculator you're going to raise a number to the power and press that button. And then I'm going to punch in the 3 and press enter, and you can see that we got 8. And I chose that one because you would expect the answer to be 8. And if you don't get an 8, then something is incorrect about the way you punched it in your calculator. So what we're going to do is evaluate some expressions, and we'll evaluate them and present our answer to 3 decimal places. So let's jump in. Let's do raise 4 to the 2.6 power. Now my base is 4, so I punch that in first. I tell it I'm going to raise it to a power, so I press this button, and then I can put in the 2.6. Because as we know, exponents don't have to be integer values. And it's an irrational number that goes on forever. But I'm going to just give it to 3 decimal places. So 36.758. Notice there's an 8-3, but I'm going to round. So if this number is lower than a 5, a digit smaller than 5, I'll just keep it at the value that it was. So 36.758 is my answer for this one. Let's do another one. Let's punch in 7.3, and now I'm going to use an irrational number as the exponent. And there is nothing that says that exponents have to even be rational. So we're going to put in 7.3 as the base. Tell your calculator you're going to raise it to a power. And then you need to find your square root button. Now my square root button is over the x squared, so you'll need to find it on yours. So because it's over the x squared, I need to press the second button to access that square root. My calculator, notice, opens parentheses for the square root. Some calculators do, some don't. You need to pay attention to whether yours does or does not. So when I put in the 11, I'm going to close those parentheses so it knows that the square root is over. So I have 7.3 raised to the square root of 11 power, and I'm going to press enter. And I have approximately 729.99, let me write it this way, 18307. That's what I see. If we're going to 3 decimal places, we're going to write it right to this place right here, to the thousandths place. So this number is greater than or equal to 5, so I'm going to round that up. So it's approximately 729.992. Let's do another one. Let's evaluate 15/19 to the pi minus 1 power. I just want to get us practice using our calculators. So the base this time is 15/19. Let me clear my calculator. I've never used the fraction button on my calculator. I'm just going to put this in as a division problem for the calculator to compute. And I'm putting in parentheses, open parentheses, so the calculator knows it has a computation to do for the base. 15 divided by 19. And then I close my parentheses. So there's the base. I raise it to, I tell it I'm going to raise it to a power. And now notice, even though I visually don't have any parentheses here, I know the calculator needs parentheses because your scientific calculator will follow the order of operations. And it needs to do the calculation for this exponent. So I'm going to open the parentheses. I put the pi in there just so that you would look for your pi button on your scientific calculator. Here it is on this calculator. Minus 1, and then I close parentheses. So I have the base in parentheses. I told it I'm raising it to a power. And then I have the exponent in parentheses because there were calculations to be done on both. And I press enter, and we get approximately 0.60 and a 27, so that will bump this up to a 3. So I hope you get this value right here. And you can play around with your calculator. You can use the fraction button if you like. I just never use it on mine, but you can try it out on yours. On the next example I'm going to show you, I will show you a way in which sometimes I avoid parentheses. You can use that or not, this depending on the problem, but you want to practice using your calculator, finding where the buttons are and how the keystrokes need to be for you to get the right answer for the problems. Here's the next one we're going to do. I'm going to get a fresh piece of paper. Let's make this one be the square root of 14 plus 2 raised to the 1.2 power. So the base definitely requires that a calculation be made, so I'm going to put in parentheses the square root of 14. So I have the square root. I have to press the second to access the square root because it's above a button on my calculator, but you might not have to on yours, just depends on where the square root button is. So I'm taking the square root of 14. My calculator opens parentheses after a square root, so I have to close them. If your calculator does not open parentheses, then you don't have to worry about closing them. Then I'm going to add 2 and close that set of parentheses. So I have parentheses around the base. Now I'm going to raise it to the 1.2 power, and out pops my result. It's approximately 8.144. I hope you're trying these on your calculator and see that you get the same results. Now, sometimes I'm not a fan of putting in parentheses. So as an alternative for this one, what I often do is calculate the base. So I'm going to punch in square root of 14. I still have to close those parentheses and add 2. So you'll notice that the base is here on the calculator, and I press enter. So it does require that keystroke if I'm going to avoid the parentheses around that base. So now what's on display in my calculator is this base. That base represented as a decimal. And now I can raise it to the 1.2 power and press enter, and notice I still get that 8.144. But play around with your calculator. See how it is that you like to enter them. And for a number of these problems, there are a variety of ways in which you could enter them in on your calculator. Let's do this next one. Let's look at 9 times 2/3 to the 5.2 power. Let me press clear. So I'm going to say 9 times, and then I have a calculation there. I'm going to open my parentheses. 2 divided by 3, there's the base, raised to the 5.2 power. And I get approximately 1.09. It's going to be a 2/8, so I'm going to round it to a 3. Now, you may have noticed that I said 9 times 2/3. What if I hadn't even put that keystroke in? Notice on this calculator, if you just use the arrows, you can arrow back to the place you would like to look or change. And I'm just going to press delete so it gets rid of that multiplication sign. So now it looks a little bit more like this. The 9 is right up against the parentheses. And notice I get the exact same answer. So that multiplication sign was unnecessary on this calculator. The 9 right up against the parentheses meant it was going to do the multiplication. And your scientific calculators know the order of operations. So when it does the calculations, it will raise 2/3 to the 5.2 power first and then multiply by 9. Let's do one more. Let's make it 200 divided by 1 minus 3 to the negative 0.5 power, 0.05 power. So here's my expression. That doesn't look very good, but it's a negative 0.05. But let's punch this into our calculators. So, again, there are numerous ways to punch it in. I'm just going to show one, though. 200 is the numerator, divided by, and now a calculation needs to happen for that denominator. So I need to open parentheses. And then I put in the 1 minus 3. Now I'm raising 3 to a power. So let's press the caret or your y to the x button or whatever button it is that tells it to raise it to a power. I have a negative 0.05. On my calculator, I need this negative. Sometimes people press a minus on a calculator where it expects a negative sign. And if I press this instead, it will give me a syntax error. And people often don't notice what's wrong on their screen because it looks very similar. But I'm going to make sure I push a negative right here. 0.05, and I'm going to close parentheses. And I get the 3741.872. Excuse me. And I've evaluated that expression. Before we move on and evaluate other expressions, I want to show you a particularly important function mathematically. Here it is, right here. I'm going to move this camera up a little bit so you can see. And it's our function that is f of x equals 1 plus 1 over x raised to the x power. Now, I'm going to not talk about it in any detail at all. I just want to show you what happens when you evaluate this function at large values of x. Look here at the beginning, I just substituted in 1. You know how to do that. You wouldn't even need your calculator, and you would get your 2. If you put in 5, you have 1 plus 1 over 5 raised to the 5th power, replacing x with 5. And you can try that on your calculator. I've already done it, so we wouldn't need to do the calculations right now. And you'll get this. So you get a number that's close to 2.5, a little bit under 2.5. When you make x a little bit bigger, here it is, 1 plus 1 over 10 raised to the 10th power. Now we're getting close to 2.6. It's gotten bigger. And now look at what happens when I put in subsequent numbers. I put in 100, and then 1,000, 10,000, and so on. And notice the values are getting larger and larger and larger, but they seem to be settling down on a particular number. It hasn't gotten even close to 3. I put in 100 and I have 2.7 and some other decimals. And I'm at f of 1 billion, and I have something just slightly over 2.7. So they are getting larger and larger, but notice from here to here, even from 10,000 to 100,000, you would have to go out 4 decimal places to see a difference. And to from 100,000 to 1,000,000, you would have to go out to the 5th decimal place to see a difference. And we say that this is converging on a particular value. I put in 1 billion and I had this value. You could put in 10 trillion to the 10 trillionth power, and it will be larger than this, but it will never get to 3. It will never even get to 2.8. The value is settling down on a number that we call E. And E is an irrational number like pi that is important mathematically. And just like you know pi is about 3.14, I'd like you to know that E is about 2.7. It's really this. Look, I have it written to 20 decimal places here. It starts with 2.718281828, but then those decimals don't repeat forever, and on it goes. Let me put a few dots there reminding you it will go on forever. But it's an important number mathematically, and it's so important that it's programmed into our scientific calculators. So now I'd like you to bring your calculator back. So here's my calculator. Let me come back in closer. I'm going to clear this. And you need to find your E button. It varies where it is on different calculators. I'm going to raise E to the 1st power on my calculator. And I'm going to show you where it is on this calculator. It's right above this LN button, because as you'll see in later videos, it is actually related to that. That exponential and this logarithm are related, so they share a button. But you don't need to worry about that now. What you need to consider is how do you get access to that E to the X button. You're looking for your E to the X button on your calculator. You might have to look it up to find where it is on the internet if you can't find it, but poke around in your calculator to see if you can find it. So on my calculator, I'm going to access the E button. Notice it automatically put the caret in because E is so commonly used as a base for an exponential. It's expecting you to put in the exponent. So I don't even have to push the caret because it's already there. And I put the 1. So I'm raising E to the 1st power, and you'll notice that's the number that I was just describing. It was about 2.718. Now the keystrokes, depending on your calculator, can vary. For some calculators, you need to push the 1 first and then the E to the X button. So you need to play around with your calculator in what way you would punch in the keys to get this value. So now let's do a few more that involve E. Raise E to the 4th power. So I could start over. I am going to remind you, if you have a calculator like this, you can go edit what is on the screen. I can just press my left arrow and come back here and put in a 4 instead of the 1 and press enter. So the value is approximately 54.598. And we have our E to the 4th. Let's do another one. Let's raise E to the negative 1.6 power. So this time I'll just start from scratch. I'm just going to clear off my screen. Again, E for me, I have to press the 2nd and then the LN button because the E is above it. So I have E to the, and now I have negative 1.6. Again, make sure you put in a negative. And I press enter, and I have approximately 0.20. I'm about to write a 1, but I see the next decimal place, there's an 8. So that means I bump up this spot, and I have 0.202. Let's do another one. How about 2e to the 1.8 power? These kind of expressions pop up frequently when you're working with e in applied problems. So I'm going to start with my 2. And as you saw in a previous problem, I don't have to push the multiplication sign. It will know there's multiplication coming. And so I have 2 and then my e to the 1.8 power. And I have approximately 12.099. Notice the next place was a 2, so I don't need to bump that one up. Let's do one more. 15e to the negative 0.06 times 13 power. Now we have to take care with this one, and I'll show you why right now. We're going to start with 15 times e to the, and now notice the exponent is this product. We need the calculator to be told this product is the exponent. So I have 15e, and notice on the calculator there's a caret. It's opening those parentheses. Whatever follows will be the exponent on the base e. So as I punch in the negative 0.06, I do not want to close the parentheses. I just want to multiply it by that 13. So notice how the parentheses look when you're typing it into your calculator versus what they look like when you're looking at an expression on paper. The parentheses are around the entire exponent. So I have negative 0.06 times 13. Let me close those parentheses. And I end up with 6.876. I hope that gives you a start in practicing using your calculators with these exponentials.